Today is the third day on section 7.1 with trig substitution, and today we're actually going to get into trig substitution on our second example. So let's go ahead and jump right in. For the first example, it says rewrite 1 over 1 plus sine of x so that it's not in fraction form. So to do this, we are going to do something that's similar to rationalizing the denominator that you learned in Algebra 2, you also did in Algebra 3. So let's go ahead and get started. So if my original problem is 1 over 1 plus the sine of x, we are going to multiply both numerator and denominator by 1 minus the sine of x. And then when we multiply fractions, we multiply like normal, we multiply straight across. So we get 1 minus the sine of x in the numerator. And then if you take a look at the denominator, if I have 1 plus the sine of x times 1 minus the sine of x, that's difference of squares. So we end up getting in the denominator 1 minus sine squared of x. Now from this point, because it's still in fraction form, let's think about things we could do. Think about our identities that we've learned, and anytime I see sine squared, I think of the Pythagorean identity. So 1 minus sine squared of x, well, that's really, so if we think about it, let me write that over here, we know that sine squared of x plus cosine squared of x is equal to 1. So if I subtract sine squared of x from both sides, I get 1 minus sine squared. So that means I can rewrite my denominator. Instead of being 1 minus sine squared, I could rewrite that as cosine squared of x. Okay? Still in fraction form, so let's keep breaking this down even more. So I'm going to break this into two separate fractions. So 1 over cosine squared minus sine over cosine squared. Okay, 1 over cosine squared. Well, 1 over cosine is secant, so 1 over cosine squared is going to be secant squared. So just when we thought we were making my one fraction into 2 was making this problem much more difficult, it got rid of one of my fractions already. So then let's take a look at this other part. So then it's going to be minus, and I have cosine squared, so I'm going to break that up into cosine and cosine. So I'm going to do sine x over cosine of x, but then I have another cosine in the denominator that I'm multiplying, because remember, to get cosine squared, I need cosine times cosine. So sine of x times 1 would still give me sine of x. So I just broke that denominator down. And let's see if we can rewrite these in terms of other trig identities or trig functions, so that way we eliminate our fractions. So my secant squared is going to stay there. Sine over cosine, that's tangent. So I have tangent of x times 1 over cosine, that's secant. So then we have tangent x times secant of x. And we no longer have fractions, so we are finished. Okay, now there's not one singular way to do every single problem. You have to look at each individual problem, think about all the identities we have so far, so it might be a good idea to have your formula sheet next to you so we can sort of think about those things. So take a moment, try the your turn, like pause the video, try it on your own. I'm going to go ahead and work through this, that way you can check your answer. Now, I will say for this one, there are 2 different answers that you could get as your solution. So I will write both of them down and you'll see them. So take a moment, pause the video, then come back and check your work. Right, so this is our one solution. Okay, it is in the correct form, not written as a fraction. But right here is where I could have went somewhere else. So I'm going to do that part now. So I'm going to take my secant and split that as to 1 over cosine. And then divided by tangent is sine over cosine. So this right here is my secant. Let me write this here. Secant divided by my tangent, just so you see where they're coming from. So I have that. And then I had times 1 over tangent, so that I'm going to keep that times 1 over tangent for now. And then I'm still going to rewrite 1 over tangent squared as plus cotangent squared. And then from here, I'm going to continue to simplify. All right, and there is the other solution. And actually, if you think about it, I know if you were to look in this book, it would say there are 2 solutions, but we could probably take my secant, break that down into 1 over cosine. My cotangent squared is cosine squared over sine squared, reduce some things, and these 2 things you will see, and that's later in the chapter, that these 2 things are equal to one another. They're the same expression, just in different forms. However, we're considering them 2 separate answers because technically they both fit the description of what they asked us to do, and to rewrite it so it's not in fraction form. I will say the second answer is the most simplified version of this. All right, so now we're finally going to take a look at example 2, and that is with our u substitution. So with just substitution. So for this example, it says u substitution, x equals 2 tangent theta, where theta is between 0 and pi over 2, to write the square root of 4 plus x squared as a trig function of theta. So that means we don't want x in the problem, we want theta in the problem. So if I have my expression 4 plus x squared, don't forget your square root, everywhere I see x, they are telling me to replace it with 2 tangent theta. So that's going to be 4 plus 2 tangent of theta squared. And again, don't forget that square root. So now let's simplify what we can. So 2 squared is 4, tangent squared is tangent squared. And then when I look at this, I see that each expression has a 4, so I'm going to factor out that 4. That becomes 1 plus tangent squared of theta. 1 plus tangent squared is going to be secant. Again, that's a Pythagorean identity. And now that I just have 4 times secant squared, I can now take the square root of both of them. So the square root of 4 is 2. The square root of secant squared is just secant. And that's all we can do. So again, pause the video, try the your turn. It is very similar to the one we just did, and then come back and check your work. All right, so we got 4 tangent theta as our answer. So you can see down here what the homework is. It should also be in Schoology in your daily agenda, weekly agenda. So if you don't get it here, just check one of those 2 places.